Okay, Devin, I'm making these videos just for you. I'm not going to share these with the entire class, so that's why I've just got one of your practice tests open and we're just going to look at it. So it looks to me, by looking at those three different problems, it looks to me like you have no problem getting your hypotheses written correctly. It's just a matter of actually getting into the right place in StatCrunch to run the test. So on this one, what you really want to pay attention to is definitely it's for a mean, right? It says mean in the questions and we see mu's everywhere on the screen. And it's only a single test, or there's only a single sample here. So we want to go into that test 1 sample area to run this one. Just open up your data in StatCrunch. Go into your T-Stats 1 sample area, and we have the raw data. We have every individual data value here, so choose with data. I think that might be one of the things that's different between these and some of the ones we've done in the past that could be throwing you. Choose the column where your data is, and then make sure your hypothesis actually matches up with what you chose, because you chose it correctly. So make sure your null is that mu is 0 and your alternate is that mu is greater than 0. So on this one, I do need to change my symbol, but that's it. Everything else is already set up so I can compute it. And there's that t-stat and that p-value that they're wanting, and this time it came out correct. Once you get that t-stat and that p-value, you use that p-value to determine your conclusion. So in this case, since it comes out less than the significance level of 0.05, we always reject the null in those cases. And that means there's sufficient evidence to go with the alternate hypothesis. So we're going to go with the alternate that you chose, which is that the mean is actually greater than 0. Okay, so let's move on. 16 was the next one you had a question about. Part A is fine. It was just a little bit of a rounding error. And part B, you also are good on because, what's going on here? Can't I scroll this down? Well, I'm not sure why that is stuck like that. But your part B is fine too. You picked your right hypothesis. There it is. No? It's still not liking me. I'm going to try to jar it loose here. Okay, there we go. Okay. So you picked your correct, again, H naught and H sub A. You picked that the mu difference is either equal to 0 or not equal to 0. What I bet was the problem here, if I had to guess, it might be that you didn't run a paired test on this. It's definitely a 2-sample test. We have a sample from University A and a sample from University B, but I see this mu difference all over the place, and that is the key that is telling me this is a paired sample. So remember, there were 2 different kinds of 2-sample tests in this unit. There's a 2-sample test for independent means, and then there's a 2-sample test for paired means. Paired means mean exactly that. It means that from each sample, we have to have like a one-to-one correspondence between the sample values. So here's a random example. If you asked husbands and wives questions, you would definitely want to match up a particular husband with his wife for the answers. You'd want to make that a matching pair. You wouldn't want to match up one husband with somebody else's wife and then compare those. That doesn't make any sense. Another thing might be if you do a before and an after question, if you maybe do a weight loss analysis and you do before weights and after weights, it only makes sense to put my before weight with my after weight. It doesn't make sense to put my before with your after. So there's this pairing that has to happen. In this one, I think what's happening is we have samples of books. So they want to make sure it's the same book from the 2 different universities, right? You want to compare the stats book to the stats book, not the stats book to the psychology book. So that's why this one is a paired sample. But really, without even thinking too much into it, when you see those difference words, or if you see sub D, that's your indication it's a paired sample. So when I open this up this time, It's definitely got 2 samples, so we go under the t-stats area, but instead of picking the regular 2 sample, I have to pick paired because of what I was seeing on the screen. Then I can choose my sample 1 and 2 to be A and B. And notice even in here it says mu sub D, so it's still using that difference terminology here. I just matched that up though with what you chose, which you chose the equal to and then not equal to 0, so equal to and not equal to. So there we go. As long as I'm in this correct area, my numbers will come out right. If you run this under the regular 2 sample area, it won't come out right. But that does come out correct then. It gives me the correct T. So it looks like here we have a p-value that is still less than 0.05 though. When it's less than 0.05, we reject the null and we say that there's evidence to go with the alternate. So there's evidence here that the mean differences is not 0 because that's what you had chosen as your alternate. You had chosen not equal to 0. Okay, then the last question you had asked about, you did a really good job picking 3 questions because they all 3 work differently. This one is also a 2 sample test for sure where they did men and women, but this time it wasn't any specific pairing. It wasn't husbands and wives or fathers and daughters or any specific correspondence. It was just a random selection of men and women. So those are independent of each other. I need to run this under the regular 2 sample area. When we run it under there, we just open it up. Again, it takes me 2 times to get it open here. Okay, we open it up. We're going to go into our, oops, went to the wrong area. Go to t-stats regular 2 sample with data. It was female first, then male, so put them in an order. And the first thing they wanted was a confidence interval, so I'll just check that bubble. And then there's my correct confidence interval, the 6.53 and 18.18 comes back. So once we've got the correct confidence interval, we should be able to see that that does not capture 0. 0 is not in that interval anywhere. When 0 is not in there, what that tells us is that these means are definitely different from each other. It's not possible that they're the same. If 0 is ever in your interval, that's the indicator that maybe it's possible that these 2 means are actually the same. Like they're so close that possibly they're the same. These are far enough, the population means are far enough apart from each other that we truly are convinced that they are different. And then again, if I want to run a hypothesis test, so they wanted you to do both on this one, you just have to go back under that same test and choose the other radio button and make sure that you have your null and alternate. So yours are equal to 0 and not equal to 0. So I'm just going to go back under here and go back to my options, and instead of confidence interval, choose hypothesis test, leave it on equal and not equal to 0, and recompute. And there comes my T and my P value, so we can come back out here. We can see how those match. So again here, when your P value is smaller than 0.05, that's when you reject. Use that sentence that when the P is low, the null must go. So the P is low here, the null must go. We have to reject it. Anytime we reject the null, that means we are going with the alternate. So it looks like there is enough evidence to say that the mean differences here, that they really are different. So the good thing you've got going for you is it does appear that you're getting your null and your alternate set up correctly. It's just a matter of keeping those 3 different types separated. It could be a 1 sample t-test. It could be a 2 sample that's either independent or that's paired. It's hard sometimes to tell whether it should or should not be paired, and that's why I like at least you getting the clue. If you see the sub D or the sub difference, that tells you automatically it's paired. So I don't see that anywhere on this paper or on this problem that's showing still on our screen. That's how I know this is a regular independent 2 sample test.